An apple falls on a man's head, and gravity is born. A Greek jumps out of his bathtub and runs naked through the streets, shouting one word. A doctor spots mold in a dish and saves 200 million lives. You learned all three of these in school. All three are wrong. And the real versions tell you something stranger about how humanity actually figures things out. Start with Archimedes. The bathtub story comes from Vitruvius, a Roman architect who wrote it down around 25 BCE. Archimedes had been dead for roughly 200 years. Vitruvius never met him and never cited a source. The method in the story would have been too crude to catch a goldsmith swapping gold for silver. Archimedes' own surviving treatise on floating bodies contains no bathtub and no shouting. Newton's apple has a better paper trail. William Stukeley wrote a memoir in 1752 describing an afternoon he spent with Newton in 1726, sitting under apple trees after dinner. Newton told him that watching an apple drop had started him wondering why it always fell straight down. Nothing hit his head, and the thinking took decades. Newton had the first version of the idea around 1666. The Principia came out in 1687, 21 years later, after Edmund Halley badgered him into writing it and paid the printing costs out of his own pocket. So if flashes of insight are this rare, what does the real thing look like? Very often it starts with a mistake that nobody was supposed to notice. On November 8, 1895, Wilhelm Röntgen was working in a darkened lab in Würzburg, Germany, with a cathode ray tube wrapped completely in black cardboard. Across the room, a screen coated in barium platinocyanide started glowing. Sealed tube, blocked light, a glow 2 meters away. Röntgen told almost nobody for 6 weeks. He ate and slept in the laboratory. On December 22nd, he asked his wife, Anna Bertha, to hold her hand over a photographic plate for 15 minutes. She saw the bones of her own fingers and her wedding ring and told him she had seen her own death. He published 6 days later. Within a year, hospitals across Europe and America were using X-rays to find bullets in wounded soldiers. 3 months after that, Henri Becquerel in Paris was trying to prove that uranium salts glowed after sunlight. The last week of February 1896 was overcast. He shoved his wrapped plates and his uranium into a drawer and waited for the weather to break. On March 1st, he developed the plates anyway, expecting faint outlines at best. The images came out sharp. The uranium had been exposing film in total darkness, with no sunlight involved at any point. That drawer was the discovery of radioactivity. Fair question at this point. If accidents do the work, why doesn't every clumsy scientist end up famous? Accidents happen constantly. Noticing one costs you something. Alexander Fleming was not the first person to see mold kill bacteria in a dish. John Tyndall described penicillin suppressing bacterial growth in front of the Royal Society in 1876. In 1897, a French army doctor named Ernest Duchenne submitted a doctoral thesis showing that Penicillium glaucum protected guinea pigs injected with typhoid bacteria. The Pasteur Institute never acknowledged the work. Duchenne was 23, got posted to a garrison, and died of tuberculosis in 1912 at 37. The observation had been made twice and buried twice. Louis Pasteur had already explained why in a lecture at Lille in 1854. Chance, he said, favors only the prepared mind. Which brings us to September 1928 and a cluttered basement lab at St. Mary's Hospital, London. Fleming came back from a holiday in Suffolk, found a stack of staphylococcus plates by the window, and saw a clear ring around a blue-green contaminant. He published it in 1929 in the British Journal of Experimental Pathology. Almost nobody cared. Fleming could not purify the substance, could not keep it stable for more than a few days, and by the mid-30s, he had largely moved on. The gap between that plate and an actual medicine lasted 12 years. In 1939, Howard Florey and Ernst Chain at Oxford pulled Fleming's forgotten paper out of the literature and started again with a chemist's toolkit. On May 25, 1940, they infected 8 mice with a lethal dose of streptococcus and treated 4 of them. By the next morning, the 4 untreated mice were dead. The 4 treated mice were walking around the cage. Their first human patient was a policeman named Albert Alexander, admitted to the Radcliffe Infirmary with an infection from a scratch. Treatment started on February 12, 1941. Within a day, his fever dropped and his eyes began healing. The Oxford team had so little penicillin that they filtered it back out of his urine and reused it. They ran out on the 5th day. Alexander relapsed and died on March 15th. The drug worked, and there was not enough of it to save one man in one hospital bed. Sometimes the delay has nothing to do with chemistry. Sometimes it is entirely about pride. In 1847, Ignaz Semmelweis ran the maternity clinics at the Vienna General Hospital. The first clinic, staffed by doctors and medical students, lost about 10% of its mothers to childbed fever. The second clinic, staffed by midwives, lost about 4%. Women in Vienna knew the numbers and begged to be sent to the midwives. That year, Semmelweis's colleague Jakob Kolechka was cut by a student's scalpel during an autopsy and died with exactly the symptoms of childbed fever. Semmelweis worked out that the doctors were carrying something from the dissection room to the delivery room on their hands. He ordered washing in chlorinated lime. Mortality in the first clinic fell to around 1% within a few months. His superiors read it as an accusation, which it was. His contract was not renewed. He was committed to an asylum in 1865, beaten by the guards, and died 2 weeks later at 47 from an infected wound on his hand. Alfred Wegener got a slower version of the same treatment. In 1912, he argued that the continents had once been joined and had drifted apart over millions of years. He pointed to matching rock formations on opposite shores, identical fossils separated by an ocean, and coastlines that fit together like a torn page. Geologists in London and New York mocked him for years because he could not say what force moves a continent. He froze to death on the Greenland ice sheet in November 1930, on his 50th birthday. In 1963, Fred Vine and Drummond Matthews found magnetic stripes on the floor of the Atlantic, recording reversals of Earth's field in symmetrical bands on both sides of the mid-ocean ridge. The seafloor was spreading, and Wegener had been right for 51 years before anyone could prove it. One more pattern, and this one involves pigeons. In 1964, at Bell Labs in Holmdel, New Jersey, Arno Penzias and Robert Wilson were calibrating a horn antenna and could not get rid of a faint hiss. It came from every direction of the sky, day and night, summer and winter. They checked every connection in the wiring. They evicted a pair of nesting pigeons and scraped the droppings out of the horn. The hiss stayed exactly where it was, about 3.5 degrees above absolute zero. 60 kilometers away at Princeton, Robert Dickey's group was building an antenna specifically to hunt for leftover heat from the early universe. One phone call connected the two rooms. Penzias and Wilson had spent a year trying to delete the most important signal in cosmology. They shared the Nobel Prize in 1978. Put these stories next to each other, and a shape appears. Somebody is doing careful, repetitive, unglamorous work on a completely different problem. Something goes wrong in a way that should be ignored. One person out of the several who saw it decides the anomaly deserves another week. Then comes the long part. The arguing, the funding, the 12 years of nothing, the colleagues who take the whole thing personally. Röntgen refused to patent X-rays and gave his Nobel money to his university. Fleming, Florey, and Chain split their prize in 1945, 17 years after a dirty plate by a window. Semmelweis got his statue in Budapest a generation after he was buried. Gregor Mendel published his pea experiments in 1866 in a small natural history journal in Brunn. He was cited roughly 3 times in 34 years and died in 1884 running an abbey. In 1900, 3 separate botanists rediscovered his paper while duplicating results he had already published. The apple, the bathtub, the flash of light, those versions survive because they are short. What actually happened was slower, more crowded, and much more human. Somebody noticed something small, refused to drop it, and then spent years convincing everyone else that they had not imagined it.